चले जो मेन चीज थी वो हमने कर ली है. Higher potential gains electrons, lower potential loses electrons. We did a few chain reactions as well. ठीक है. Most of the equations are going to be easy. लेकिन electrochemistry is still you get difficult questions on this. ठीक है. All you have to figure out is if you have a reaction, who gains electrons, who loses electrons. Highest gains electrons, lowest loses electrons. ठीक है. As long as it's your reactants and products that are gaining or losing electrons. So anyways, I'm going to do another thing, which is non-standard electrode potential. So as a right now, as a non-standard electrode potential is simply E. Okay, it's the electrode. It's not E naught. वो जो not होता है ना, that's for standard conditions. ठीक है. So that just simply means standard conditions are not used. So standard conditions are not used. As a non-standard conditions. So it's very simple. ठीक है. Your potential will change. ठीक है. So the electrode potential is going to change if you change the conditions, because remember, all electrode reactions are reversible reactions. For example, I have this reaction, Cl2 plus 2 electron, and that is in equilibrium with, so that is in equilibrium with 2Cl minus 1. And the standard potential for this is 1.36. So it's 1.36 volts. You can remember this is the standard E naught. अच्छा Cl वाला हमने किया भी था. Let me just try and find out where's the Cl electrode. अच्छा this over here was the Cl electrode. So copy कर लेते हैं. Second. ठीक है. अच्छा this one over here, this is the Cl electrode, and let's imagine at the moment this is Cl2, it's no longer at under standard conditions. The Cl minus 1 concentration is no longer 1 mole per dm cube. ठीक है. You've got a platinum electrode and इसको भी हटा देते हैं, पहले किया था. अच्छा, so this is 1.36 volts, but under standard conditions. What will happen? Okay, what will happen if I increase the concentration of Cl ions, right? Okay, if I have more Cl ions and I start adding more Cl ions into the solution, okay, so I've increased the concentration of Cl ions. I'm using non-standard conditions now. Standard में तो था 1 mole per dm cube. So if I increase the concentration of Cl minus 1 ions, right, then where would the equilibrium shift? Where will this equilibrium shift? That if I have more Cl ions, that's more Cl ions would start losing electrons, right? The equilibrium would shift backwards, and they would start to lose electrons, and your platinum electrode would have more electrons on it, and your potential would decrease. It will become more negative. It's going to become lower. The idea clear? Is this point clear? Okay, if I change the conditions, if I have, it was in equilibrium, right? And if I started adding more Cl ions, then more Cl ions are going to produce a lot of electrons. They're going to start losing electrons, right? So अगर वो electrons lose करते हैं and you got more electrons on this, then the potential would be lower. It's going to be more negative, right? ये clear है? Shan, is this clear? Umar, Alicia, clear? अच्छा, and vice versa. Okay, if I, so it's like an equilibrium. It's like an equilibrium. You alter condition. Remember Lee-Shatler principle. You alter conditions. If the equilibrium shifts to the left, this is what's going to happen. Okay, if your equilibrium shifts to the left, depending on whatever you do to the conditions, that means more electrons are going to be produced. More electrons are going to be released. And if more electrons are released, then the new potential, the potential E decreases. It becomes more negative, it becomes lower. Vice versa, if I somehow push this equilibrium to the right, then what's going to happen? How can I push it to the right? If I increase the concentration of Cl2, if I increase the pressure of Cl2, if I have more Cl2, right? If there are more Cl2 molecules, then those Cl2 molecules will start to, gain electrons if I have more of them. So let's say there's another Cl2, there's another Cl2. If I have more Cl2, they will start to gain electrons. And तो यहाँ पे electrons कम हो जाएंगे. It's going to become more positive, right? So if the equilibrium, इसका जो दूसरा opposite होगा ना, if the equilibrium shifts to the right and the reaction starts to gain electrons, ठीक है, इसी को copy कर लेते हैं. So the same thing in the opposite direction. If it starts to gain electrons, so more electrons, instead of being released, are gained by the potential increases. Okay, so simple idea, which is this one, that you've got non-standard potentials. Okay, depending on the conditions, the equilibrium, if you change the condition, abhi isse pehle the only difference was we had standard conditions. Now we have non-standard conditions. So if I want to make this potential, I can change this potential. I can shift the equilibrium forward, and there are many ways. The Shatler principle of beach mein what you can do is you can increase the pressure. So if you increase the pressure, the equilibrium would shift to the right. You can decrease the concentration of Cl lines, the equilibrium would shift to the right. If I want to push it backwards, increase the concentration of Cl lines, decrease the Cl2 gas pressure, right? The equilibrium would shift to the left. Lee-Shatler ka pata hona chahiye how to actually make the equilibrium shift right or left. Just a normal equilibrium mein karte hain. You're going to do that. If it moves forward, it's going to become more positive. Its potential would increase. If it moves backward, its potential will decrease. Is that clear? Is this clear? Only for gases, yes. I mean, this one has a gas, right? So for example, if there's a reaction and it doesn't have a gas, let's say I've got in the previous one you had a gas. Now this one doesn't have a gas. You got Fe3 plus 1 electron, and it's in equilibrium with Fe2 plus. Now I can't use pressure over here because all of them are aqueous, right? The pressure only works for gases, yes. अच्छा इसका जो standard potential है, that's 0.77 volts. Now, if I want to make it more positive, what do I need to do? I need to push it to the right. How can I do that? So when will the potential increase? अच्छा इसका ख्याल रखना है कि when you're talking about non-standard potential, you just write E. There's no not on top of it. ये जो not है ना, this is not written on top of that. ठीक है? So if I want to increase the potential, what do I need to do? I need to push it to the right. Equilibrium should shift to the right. And how can I do that? I can either increase concentration of Fe3 plus, or I can decrease concentration of Fe2 plus. दोनों cases, well, in both cases, the equilibrium would shift to the right. ठीक है? And vice versa, do the opposite if I want to do the opposite. ठीक है? So the new potential would be higher if I do that. So the new potential might be, let's say, it's not going to be a major difference. Just you can only push the potential slightly higher and slightly lower. You can't create a big difference. I mean, this 0.77 cannot become 1.77. But it might become 0.9, it might become 0.95. So it's not going to be a major difference. It would still be around 0.77. Just very slightly higher, very slightly lower. Okay? We are the ones who are increasing Fe3 plus. But we are the ones who are controlling the conditions, right? So if I want a higher potential, what I can do is I can have more Fe3 plus. If I have more Fe3 plus, that Fe3 plus will go and consume all the electrons. So आपका जो electrode होगा, it's not going to have a lot of electrons. यानी अगर वापस उस पे जाए ना, like over here, let's look at the sodium electrode. If I want to make the sodium electrode even more negative, so I can get rid of the sodium ions in the solution. If I get rid of the sodium ions, more sodium ions will be produced, and more electrons are going to be produced, and it's going to become even more negative. If I remove sodium ions, the equilibrium would automatically shift forward. It's going to start producing more sodium ions, and even more electrons are going to be produced, and it's going to become more negative. Okay? Is the idea clear? अच्छा उसकी 1 second. अच्छा plus why do we need to do that? Okay, the reason we do it is because we want more current, right? We want like if I've got a UPS battery, right? I want to derive a higher current. I've got a cell. I've got an electrochemical cell. I mean, we use cells, batteries everywhere, right? So something similar is happening. One electrode is producing electrons. The other one is accepting electrons, right? So if I want to increase the current, I would have to do that. The question is mostly once they like where's an electrochemical cell? Let me just copy an electrochemical cell. So most of the batteries around you, they work on a similar concept, right? So for example, I've got this electrochemical cell. Okay, let's say that's my battery. Okay. All these lithium-ion batteries, etc., they all work on a similar concept. So the question would be that they're going to ask you, is gonna increase the voltage. That how do you increase the E0 cell? How do we increase E0 cell? That's the question. So the answer to that is like how do we increase E0 cell? Okay, the lower potential must be made even lower. So I want to, you can either decrease the copper, decrease potential on the copper electrode. So you can do two things. Decrease Cu2 plus Cu potential. Or vice versa, you can do, you can either increase, sorry, इसका decrease नहीं करना, इसका increase करना. The higher must be made even more higher. The right side potential should increase, and you should decrease the sodium. So you should decrease the sodium electrode. So the question, I want to increase the potential. 3.05 volts, I want a higher potential, maybe 3.5, maybe 4. So let's copy this. Our source setting and what can be done. So if I want to increase the potential, I need to shift it to the right? I need to shift it even more to the right. So the way I can do that is I can increase the concentration of copper ions. Right? So more current would flow. Why would more current flow? Okay, what are copper ions doing? The electrons are coming from the other side, and copper ions are the ones that are gaining electrons, right? So if I have more copper ions over here, electrons will be gained at a much higher rate. So if I want to shift it forward, the potential will increase on the right side. So it will become greater than 0.34. So instead of 0.34, it might become let's say 0.40 volts. And the lower one must be made even lower. So right now it's minus 2.71 in equilibrium, and that's minus 2. So I need to shift it further to the left. And the way I can do is I can decrease the concentration of sodium ions. If I decrease the concentration of sodium ions, the equilibrium will shift to the left and it will become even more negative. So instead of 0.71, it might become minus 2.90. So automatically your potential difference is now higher and the electrons will flow much quicker. Okay. So you'll get questions on this about increasing the E0 cell or to speed up the reaction. So all you have to do is make the higher even higher. Higher karna hai, you push it more to the forward direction. If you want to make it lower, push it back in the backward direction. Make it produce more electrons. It's going to become more negative. ठीक है? ये clear? ये वाला example clear है सारों को? अच्छा, so I think we are probably sorry, इसमें बहुत सी चीजें रहेंगी. It's now you can also measure the non-standard potential. Abhi to it's qualitatively speaking, like the potential will become higher and the potential will become lower. Like we didn't do any calculation. This is just a made up value. I just said that 0.34 ki bajaye, it's going to be 0.40, right? So right now it's just a made up value. What you can also do is you can measure the new potential. So how do we exactly measure the new non-standard potential? So how to measure your non-standard potential, right? So there's an equation which is known as the Nernst equation. So this Nernst equation is that the new potential is the old potential E0 plus 0.059 divided by Z log of the oxidized species concentration over the concentration of the reduced species. So that's what the Nernst equation is. Okay, and that is specifically for calculating the new potential. So for example, it's gonna just remember this, the oxidized species. Which is the oxidized species? Remember, in any equation, you'll have oxidation happening and reduction happening. Forward is reduction, backward is oxidation. It's a reversible reaction, right? So the oxidized species is the one that's on the left side. If the equation is written in the conventional way, okay, forward may gain hai, backward may loss hai. So this is the oxidized species, the one on the left. The one that was formed after oxidation. And the reduced is the right side one. Okay, that is the one that is formed after reduction. Achha, you wouldn't get a question on gases. For solids, remember the concentration is always taken as 1. The concentration would be always taken as 1. Solids have a constant concentration. So if I have the copper roll example, okay, they might say that there's a copper electrode. And the copper electrode, this is the equilibrium. Copper ions plus 2 electrons in equilibrium with copper. And the E naught is 0.34. So under standard conditions, the E naught is 0.34 volts. But in their electrode, the concentration of copper is 0.01 mole per dm cube. And it's a lot less than 1 mole per dm cube. Where do you think the equilibrium will shift? Backwards or forward? I mean, it should have been 1 mole per dm cube, but they're using 0.01 mole per dm cube. So where would the equilibrium shift? Okay, Shian, as it's going to shift to the left, right? You can, instead of using 1 mole per dm cube, you're using a very low concentration. So the equilibrium will shift to the left, right? So that means the potential should actually be lower because the new potential should be lower. It should decrease. ठीक है, backward जाएगा, it's going to produce a lot of electrons. Your electrode will have a lot of electrons on it, and the new potential will decrease, right? So अब हम वो calculate कर लेते हैं, like what's the new potential? So we're going to use the Nernst equation. It's E is equal to E naught. E naught is 0.34 plus 0.059. That's a Z. I forgot to tell you what Z is. Z is the number of electrons. That's the number of electrons in the equation, which over here in this case it's 2. Of a log of oxidized species. Oxidized species is the one that's on the left side. That's 0.01. And a log reduced species. Reduced species is a solid, so that's 1. So मुझे इसका answer बताओ. What do you get for this? Or log, remember, is a button on your calculator, so you can just use log. The 0.059 is just a constant. You don't have to understand the equation. It's just an equation that based on the concentration of the two species, it just tells you the new potential. तो क्या बना इसका new potential? Like, has anyone calculated this? So it's coming out to be 0.281, right? So that's it. You said it was going to decrease. It did decrease. It's 0.281 moles. So just remember the Nernst equation gives you a value for the new potential. Okay, the new potential is what the new potential is going to be. If you change the concentration under standard condition, it's going to be 1 mole per dm cube. It should have been 0.34 volts, but since you're not using standard conditions, or Nernst equation सिर्फ concentration के साथ काम करती है, otherwise it's not going to work. There are many versions of the Nernst equation, but the one that applies to you and your syllabus, that's the one with concentration. So they won't give you a question on gases, but there are lots of electrodes that have gases in them, so you won't get a question on gases. All you're going to get is okay, concentration given hogi of they're going to give you an electrode. They might decrease the concentration, they might increase the concentration. You can just plug in the values into the equation. Z is the number of electrons. 0.059 is just a constant. E naught is the standard potential that it should have been if standard conditions had been used. And based on that, you can calculate the new potential, which is 0.281. If the equilibrium shifts to the left, depending on what you do with the conditions, it's always going to decrease. If the equilibrium shifts to the right, depending on whatever you do with the conditions, the potential will be higher. Okay? ये clear है सारों को? I said the same thing. So we can. I said this part. Okay, remember it's. But इसमें बिल्कुल simple रखना है, ठीक है? कहाँ पे? This part. If it shifts to the left and more electrons are produced or released, the potential will decrease. If the equilibrium shifts to the right, with whatever you do with the conditions, electrons are gained and the potential will increase. ठीक है, तो equilibrium जो है वो forward backward shift होगा. Plus you can calculate the new potential. तो बस ठीक है, अब थोड़े से questions we can try. There's some of the questions so apart from we kind of done with the chapter, okay? Most of the chapter. I mean, there's still some things left, but most of the topic is we're done with it. Electrolysis is important, which is still left. Let's say 2020 वाले करते हैं. एक सेकंड है, इसकी कॉपी क्रिएट करना है. Starting with ये भी छोड़ देते हैं. Easy ones first. So this one. I said let's try in this one quickly. First one. I said we're just doing the easy ones. We still have some stuff to do. Define the term standard electrode potential. So it's the potential difference calculated between. How do you measure the standard electrode potential? You measure it between a standard electrode and a reference electrode, which is the standard hydrogen electrode. So it's the potential difference calculated between a standard electrode and a standard hydrogen electrode. Okay, that's the first thing that we did. I said draw a fully labeled diagram used to measure the standard cell potential of this electrode versus this electrode. Now you can see that's a gold ion, which is aqueous, and gold. So that electrode is this one, that the gold will be the electrode, Au, and the solution will have, so let me, so your solution will have Au3 plus ions. That's one electrode. The other one has a gas in it, gas and aqueous, NO and HNO3. So for a gas, you would need a gas jar. And the NO gas will be pumped into this gas jar. And in that gas jar, there's going to be a platinum electrode. And nitric acid is aqueous, so that will be part of the. So nitric acid will be a part of the solution. And you'll add a voltmeter between them because he's asking you to measure the potential difference, cell potential. And there's one thing that is missing. What is that one thing that's missing? So bus salt bridge beach में डालना है, ठीक है? So you're going to add a. So you're going to add a salt bridge. Label everything. This is going to be at 1 atmosphere pressure. The nitric acid will be having, okay, he's using the word standard. There's a knot on top. So that's, you're going to write, this is going to be 1 mole per dm cube. The Au3 plus ions in the solution will also be 1 mole per dm cube. This one is your salt bridge. Okay. So that's your diagram. Up here he's asking, given 3 equations, write an ionic equation to show the spontaneous reaction that occurs when an electric current is drawn from the cell. So one of the electrodes is the Au3 plus and Au electrode. It's this one. And if you compare it, this is the higher potential, right? But if you go back and have a look at the one of the electrode was this one, and it is the higher potential. So that's the one that's going to gain electrons. Okay, so 1.5, right? Okay. So that is your 1.50 volts. The other one is your NO and HNO3. So they've given a table. So NO and HNO3. So I think it's this one, and that's your lower potential. The NO gas with HNO3, that's this one. That's the lower potential, and that's the one that's going to lose electrons, right? So these were the 2 electrodes. You didn't have AuCl4 minus 1, so this equation is not relevant at the moment. He's specifically talking about the cell when an electric current, when the cell starts working. When he says that the electric current is drawn from the cell, that means the cell is working, right? So this is one electrode, this is the other electrode, higher gains, lower losses, right? And the electrons are already balanced, so you don't have to, you just have to add up the reactants. Au3 plus pehle wale mein. And I've got second one with reactant here, that's NO gas plus 2H2O. So what are my products? In the first one, the product is Au solid. In the second one, the product is NO3 minus 1 and 4H plus 1. And calculate the E0 cell for the reaction. So E0 cell will be, just calculate the difference. It's going to be a reduction potential minus oxidation potential, 1.50 minus 0.96, and that's going to give me 0.54 volts. ये क्लियर है? चलो बाकी फिर अगली दफा ही करेंगे पास्ट पेपर्स, ठीक है? विल ट्राई एंड कंप्लीट द टॉपिक फर्स्ट एंड देन विल डू मोर पास्ट पेपर क्वेश्चंस, ठीक है? इसके चलो ठीक है, ओके एवरीवन। हाफिज।